Hey guys, what's up? Welcome back to another episode of the Weekly Coder. I am Chris, and today we are going to continue on with our Pac-Man clone. Okay, so just to kind of refresh where we left off last week is we added the animation for Pac-Man and we added directional controls and we also allowed Pac-Man to move around the board freely. So let's just have a look and see what that looks like here. Okay, so initially Pac-Man's just kind of sitting there waiting for us to do something. So we can press right, and Pac-Man will start moving right. We'll start moving up, left, down. So we can pretty much go wherever we want. There's no collision detection to check whether or not we're hitting a wall. There is nothing going on that is going to restrict our movement whatsoever. Okay? So one way around this is that we could actually do collision detection and then have Pac-Man stop when he gets to a wall and continue on if the user presses the right key to make Pac-Man continue to move in the direction that he's supposed to be moving in. But to actually, because Pac-Man is actually such a simple game, there doesn't need to be, we don't really need any collision detection. Collision detection is just going to be too expensive. It's going to, use too many CPU cycles to do all those calculations for collision detection. So instead what we're going to do, and you guys may have noticed this episode is entitled Nodes, is we are going to utilize nodes to allow Pac-Man to move at certain points in the game to specific directions. So what do I mean by nodes? Let's suppose, for instance, that there's a node when Pac-Man first starts. So let's go ahead and stop this. All right. So Pac-Man right now is sitting right here. Okay. This is Pac-Man's current position. So let's imagine that we're going to start moving Pac-Man to the left. Okay, we're at 14 and 7, so I'll just remember those. So we'll start moving Pac-Man to the left, and we are now at an intersection, and we want to say, hey, since we're at an intersection, we want to know where the next intersection is from this intersection. So from here we have two possible intersections, and I'm going to refer to those as nodes. Is that we can either go this way, or we can go this way. So if we decide we're going to continue going this way, we'll get to the next node. So from here, again, we're going to decide, okay, do we want to go this way, or do we want to go down? Well, let's say we want to go this way, continue on. We get to the next node. Pac-Man stops for a frame, okay? And we have another decision. Do we want to go this way to this node? Do we want to go this way to this node? Or do we want to go this way back to this node? So we have three possible nodes we can go to. And here it becomes even more interesting. If we move up to the next node, we now have four options. We can either go over here to this node, to that node, or sorry, to this node, or to this node. Okay? So the way that we're going to do this is we are going to first select all of the intersections and add the node script that we've created here. We're going to add that to all of the points that are intersections, okay? So let's go ahead and start that by, we're going to select this, and this one, and this one, and this one, this one, this one. Okay, so one thing I want to do is, since we've got these tagged, selected rather, sorry, we are going to go ahead and create, let's see if we can do this, create an empty. Nope. That did not work out how I had hoped. So let's go back up here. Alright, so I'm going to go ahead and create this, and we'll call this call these nodes. Yeah. So let's go select again, and I'm just going to hold down the command button to select multiples. Alright, so let's take a second and just kind of reflect on what we've done. We've had our pellets game object, which we created, which was an empty. This was created in the previous lesson, maybe not this one, but the one before. Yeah, the one before. The first tutorial is when we created this. And what we did just now is all we did is we found all of the pellets that are intersections where Pac-Man could potentially turn into another direction. Okay. What we did is we created an empty called nodes, and we created another empty called non-nodes. Then we found all the pellets that can be intersections, and we basically made them part of the nodes game object. Okay, so that now we have a nice compilation of all of the pellets that can be used as nodes. So if we quickly scroll through them, we should see that only pellets that can be intersections are inside of here. Okay, so we're just gonna scroll through them really quickly here, just to kind of make sure. Okay, so we're kind of using these pellets as two things. One, these are the pellets that Pac-Man is going to eat for points. And two, we're going to be using some of them, the ones that are at intersections, and we're going to add a node script to these pellets. And the way we're going to do that is we're just going to go in here, and we're going to shift select all of these, and we're going to just drag the node script over. Okay, so now each one of these pellets has the node script attached to it. Okay. All right, so now that we've got the node script attached to our nodes, we're going to go ahead and launch this script here. Well, not launch it. We're going to open it up so that we can edit it within MonoDevelop. And as you can see, the node script is basically empty, just like any other script that we've ever started with. So the first thing we're going to do is we're going to create a public array, and we're going to create this array to be a node array. Okay, so I'm going to explain that in a minute. I'm going to call this one neighbors, and then we're going to create another array, and this one is going to be a vector2 array. And this one we're going to call valid directions. So we're going to get rid of the update method because this script is not going to be running any kind of game loop. So with what we've got right now, this is going to be enough for us to continue working on. And after we get done with this next part, which is going to be oh so tedious, and you guys are going to love me for this, but on the upside, You do this once, and then you should just be able to continue reusing this kind of same thing for the next levels of Pac-Man. So every level just gets harder with, the Ghost AI being, we'll get into all that. But anyways, you should be able to use this for every single level. So we're only having to set this up once. So what we've got here is we're basically defining a variable and setting its type to be of node. Now, node is the class that we're in. So what do we mean by neighbors? Okay, so let me just kind of save this script and close it. Now when we go to one of our nodes, let's say, okay, so we'll start with this one. All right. If we look at our inspector, we'll see two properties here. One neighbors and the other valid directions. So if we expand both of these out, we can see that their size is set to 0. These are arrays, so we have to tell it, okay, well, how big is this array going to be? And then we have to assign the objects to the array for each one of our array indexes for the size that we're referring to. So what we're going to do is, for instance, with this node, okay, we've got, let's see here, we've got this node that we can move to, or we have this node that we can move to, or this node that's behind the arrow here. So what we can do is we can let this node know which nodes are neighbors to this node. So because we don't want Pac-Man to think that, okay, well, we're at this node and, oh, this is a node, so we'll just move from here to here. Well, that's not a possible movement. We don't want to allow that to happen. We want Pac-Man from here to be able to go either this way, or that way. So we have to tell it, okay, well, this is a neighbor he can go to, this is a neighbor he can go to, and this is a neighbor he can go to. So we have 3 possible movements from this node. So we tell our neighbors array that we're going to have 3 elements within there. Okay? So now we've got elements 0, 1, and 2. So what we're going to do is we're going to take this, okay? Actually, here. So this neighbor, if we click on it, we'll know it's pellet 42. Okay. So now if we go back onto our node, we can click this button, and we look for pellet 42, and double click that. So now we've assigned this node to the first index in the array. And let's go ahead and tell it that we have 3 valid directions. Okay. And we've got X and Y's. Basically, X's go horizontal, Y are vertical. And to represent up and down, or left and right, so left would be 1, and right would be -1, or sorry. Right would be 1, and left would be -1. I don't know if I'm backwards to you guys in the camera, probably. Up would be 1, and down would be -1. And that's how vector 2's are defined here. So, and that's how we define directions with vector 2's, just 1's and -1's. 0's would mean no direction, vector 2.0. So, since our first neighbor node in the index 0 is downwards, okay, so that means that Pac-Man can move downwards from this node to this node, okay? That means that our first index in our valid directions is going to match that, and we're going to say we can move in the y direction -1. Y -1 x 0. So this node, the only possible movement for Pac-Man to get to this node from here is going to be down, and down is represented by x0, y -1. Okay. So our next node is going to be this one. This one's called pellet 36. So if we go back to our node, click here in our element 1, and we select pellet 36. Pellet 36 is a movement to the right. So we're going to allow x to be 1, y to be 0. Okay? For our next node, we've got this one here, which is pellet 62. So we go back to our node, we click on this button here, and we select pellet 62. Pellet 62 goes to the left, so element 2 is going to be x -1 and y or y0. Okay. So any movement in left or right is only going to modify x depending on which direction you go. If you go to the right, x is going to be a +1. If you go to the left, x is going to be a -1. With the y's, the only movements are up and down. If you're going up, you've got a +1. If you're going down, you've got a -1. Be sure that when you're doing this, when you're assigning all the neighbors to a node, okay, that you're actually matching these. So like I said here, element 0 is pellet 42. Pellet 42 is this one right here. Element 0 in the valid directions is -1. So we're telling it that because we're going to be selecting elements out of both of these arrays at the same time. So we're going to say, can Pac-Man move down as a valid direction? And we say, okay, yes, he can. Which node is going to be his next node? It's going to be pellet 42, because these two match up. Same thing with 1 is going to move to the right. That's pellet 36, which is over here. That means that we're going to be moving 1 in the x on element 1. Element 1 here matches pellet 36. Okay, element 2, -1, x, we go left. That means 62 is right here. We can go left all the way up to pellet 62. That's its neighbor. Okay. So what you have to do, unfortunately, is go through every single one of these pellets and define all the neighbors and valid directions. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 52. So 52 times you've got to do this. So I am going to do all of these right now. So I hope you guys do the same. I am going to go ahead and just fast forward through this whole thing because God knows you don't want to watch me do this. It's going to take forever. So I'm going to go ahead and just get this started. And I'll see you guys in a minute. All right, so we've got... Okay, let's take a quick break. I just realized, you know, here we're going to make things a little simpler. Is instead of inputting all of the valid directions along with the neighbors, all we're going to do is input the neighbors, and then we are going to write a little script in our node script that is going to basically populate this valid directions array based on the neighbors that we have, that we've selected. Okay, so that's going to make this go much faster. So basically what we're going to do is we're going to select the node. All right, so we're at pellet 14 right now. And we're going to say, okay, well, we've got 1, 2, 3 possible moves. So we've got 3 neighbors. And our neighbors are going to be 10, 45, and 25. Okay? So 10, 45, and 25. And that's it. Move on to the next one. Okay, so that's all we're going to do. So again, this one has 2. So we'll do 2. And this one is 14 and 28. So we got 14 and 28. Okay. So I'm just going to keep going like this, and I'm going to just fast forward through all of it, and I'll see you in a few minutes. Or actually, for you, it'll be like a second or 2, maybe 3. So I'm going to try to do this as fast as I can. Alright, that is finally over, and it was excruciating. So, now that we've got all the neighbors selected for all of our nodes, let's just have a quick look through and make sure that every single one of these has neighboring nodes assigned. And so far so good. And they all have nodes or neighbors assigned. Okay. One thing I'm going to mention, and we're going to get into this later, I'm not going to do it right now, right this minute, because right now we just want to learn about nodes and how they work and how we can make Pac-Man move from one node to another. So let's work on that first. So here, well, yeah, the other thing I was going to mention, while not getting too deeply into it yet, is we need to create nodes here, 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 you know, at all the intersections. Here and here for teleportation from this side to that side. But we don't want to create pellets because Pac-Man in the game doesn't have any pellets in that specific location to consume. So we're not going to create any pellets for Pac-Man to consume. So we're going to be a little more sneaky about it, and I'll show you how to do that in a little bit. Maybe next video. But for right now, let's go ahead and write that script that's going to get us the valid directions for each one of the nodes. So to start with, what we have to do is we have to actually initialize the valid directions vector2 array. So what we're going to do is we're going to say valid directions equals new vector2, and we're going to pass in neighbors.length as the size for the array. Because remember, this script is attached to every single node, so it is going to run on every single one of these nodes. And it's in the start method, so it's only going to run on initialization. So when we first initialize, we want to know how many neighbors there are. And we want to create our valid directions array with the size of how many neighbors there are. So if there's 2, it's going to instantiate our valid directions array with exactly 2 elements that we can use. So 0 and 1, right? Okay. So the next thing we want to do is we want to create a for loop, and we want to iterate over the neighbors array. So we're going to say for int I equals 0, I is less than neighbors.length, I plus plus. Okay. So we're iterating over the neighbors array, and the first thing we're going to want to do is we're going to want to create like a temporary variable that we're going to store each one of those nodes in. So we're going to call this, we're going to create a node, and we're going to call this neighbor, and we're going to set it equal to neighbors and the index of our current increment, or our current value of I, which at the beginning, of course, of a for loop is 0, and then as the for loop runs, it's going to increment that I value to 1, 2, 3, 4, and so on. So for every neighbor that we have, we're going to create a node neighbor, okay? Okay, so then from this point on, we need to find out what our actual direction is going to be. So like to this neighbor, is it going to be left, right, up, or down? And the way that we do this simply is we're going to create a vector2, and we'll just call this temp vector. And we're going to assign, what we're going to do is we're going to take our neighbor transform local position, which is also a vector2, or a vector3 actually, and we're going to subtract our transforms local position. Okay? So what we're doing, let's see here. Yeah. So basically what we're doing is we're subtracting the position of our node from the neighboring node, okay? And then finally what we'll do is we'll store the normalized value of that, okay? So either -1 or 1 in each x and y location in the valid directions array at the index of where we're currently at. So we're going to take the temp vector and normalize that by just calling the normalized property on the vector and store that in this specific index that we're at for neighbor. So if we're at element 0 for neighbor, we're going to go into valid directions at element 0, and we're going to store that temporary vector that we've created and as a normalized vector, okay? And that's going to store our valid direction. So that's going to either store vector 2.up, vector 2.down, vector 2.left, or vector 2.right. Yep, that should be that. So that should actually create all of our valid directions for us for the array. And we can actually test that if we save this script and then press play. And we have no errors, which is wonderful. So we can go back through our nodes and look at all of our pellets, and they should have matching valid directions assigned to them. And as you'll see as I'm scrolling through all of these, this is working perfectly, just like it should. Don't we love it when things are working perfectly? So now that we've got nodes, we've got neighbors, and we've got valid directions, our next video is going to be moving Pac-Man from node to node, okay? And so there'll be no more going through walls or any of that stuff. So Pac-Man will be restricted, and that's going to be the next video. We'll call it moving Pac-Man from node to node, okay? So again, thanks for tuning in this episode of the Weekly Coder. I appreciate you guys keeping up with me and commenting and liking the videos. Really means a lot to me. If you like the video, give it a thumbs up. If you gosh, sometimes I get brain dead. If you want to, yeah. If you'd like to be informed of future videos, then click the subscribe button, and don't forget that bell button too, because you got to click the bell in order to actually get notifications of new videos. Something YouTube did. I don't know how long they've been doing it for now, but I just noticed it not too long ago. So, thumbs up if you like it, thumbs down if you didn't. Comment down below if you've got questions, and then subscribe. Anyways, I will see you guys next week.